Okay, so let's start, I think. So, yeah. Okay, I think we can start with introduction. We have sufficient people. We can have introductions. Yeah. And you can start.
Raj Kapadia from MSc.
MSc University. And yeah. So you have done C programming and
C++.
C++. Okay. Data structures. Okay, good.
Purvan Shah from MSc.
Purvansha.
Harsha.
Okay. Harsh.
Fahad Sheikh from MSc.
Huh?
Fahad Sheikh from MSc.
Pahaj. Okay.
Aizan Sheikh MSc.
Fine. So let's get started with introduction of Java. Fine. Okay, it will be repeat for you slightly. For 2 days, I think you'll have to bear. Okay. Okay, so let's start with this question. Yeah. Anyway, you might have might have read something about Java already. Okay, so, some common things, yeah. So the question is, what is Java? Yeah. So what is Java?
Programming language.
Okay. So one answer is it's a programming language. Okay. What else is Java? Java is name of a programming language. Java is name of, huh? Yeah. What else? Anything else that is Java? That's also called Java. Huh? Yeah. Java is name of a programming language. Yeah. What else? Yeah. It's a programming language, and what kind of programming language? It's a object-oriented programming language. Yeah. Then maybe there's something which is being attributed to the language, but yeah, it is something else. It's slightly different, but yeah. Anything else you know about the Java language? Whenever someone talks about Java, he says yes, it's an object-oriented programming language. What else is also talked about Java? Platform independent, right? So we say Java programming language is platform independent. Fine, but okay, that is very common term. Yeah. But it's more from a marketing point of view. And it's marketing term that it's a platform independent programming language. Okay, the actual idea is that Java is name of a, like, it's a programming language. There's a separate thing. So it's a programming language. And every programming language has what? It has a syntax. There are rules. Fine, syntax is everything. So there is actually a specification for the language. So we have something called, you'll find a documentation for this called JLS, Java Language Specification. You can just search for JLS PDF file. You'll get a PDF file. Fine, it's good to keep this. It's a full Java language specification, specifications for the programming language called Java. Okay, fine. Like we have one specification, so it's talking about the language. So similarly, there's another aspect. Okay, there's something called platform. So Java, there's also a platform by the name of Java. Java is name of a platform. Fine, Java is programming language, Java is platform. Fine. So there are two separate specifications managed. Okay. When we say platform, it's like a machine. Okay. So we have a Java platform, and for this, the specifications, if you are looking for specifications, just like we have JLS, Java language specifications, we have something called the JVM specifications. Sorry. So you can search for JVM specifications. Fine. And that's a separate PDF which is managed. Okay. Fine. So we have separate specifications managed for a language, and there's a separate specification managed for a platform. The two are different. Language is one, platform is another thing. Okay. On this platform, see, we have a language which is supported by a platform, right? So this language would work on so and so platform. Okay. So that way, the Java platform, there are more languages other than Java which also work on the Java platform. See, when someone was saying, okay, Java is a platform independent programming language. No, the language is not platform independent, but this language was designed to work only on one platform. And that platform was Java. Right? This Java language works only on Java platform. Okay, but this is Java is not the only language to work on the Java platform. Okay, platform is separate, and on this Java platform we have other languages which will also work on Java platform. Fine. For example, very common languages which are available also on Java platform. No, you don't have C++. Okay, you'll have something like you have heard of Python. So there's a version called Jython, Python on Java platform. Find the Python which works on Java platform. You have Ruby. There's also a JRuby. Fine. You have something called Scala. Okay. You have something called Clojure. Fine. I think you have some subjects on AI. Yeah. Achha, it's in the last sem. Okay. Artificial intelligence. Yeah. Okay. You may come across that. So I think there's a language called Lisp or something which is being used. No. There'll be some language like Lisp. Fine. It's a functional language, more closer to a functional language. So yeah, Clojure is like that. It's a similar language. But yes, again, the idea is it's on the Java platform. It's fine. We don't have the whole list, but it is said that we have more than 100 languages on the Java platform. So there are over 100 languages again on the Java platform. And so Java is a name of a platform. What else is Java? On the lighter side, not technical things. What else is name of Java? Java is also name of anything else, you know? So it's not about programming any longer. You can talk other things. Yeah. Java is name of, you know, not heard of things. Anything else which is Java? You have not referred or seen any Java books, have you? Have you referred or seen any of the Java books? Or when you look for Java, you find some symbol, icon. Why?
Java is a coffee beans.
Java is, there's one brand of coffee called Java. So Java is name of a coffee brand. Okay, Java is name of what else? It's name of an island in Indonesia. And we have an island in Indonesia called Java. And on that island, what's the language they speak? The native language they speak? That language is It's not on the Java platform, but let me put it's Javanese. That's the name of a language, spoken language, not a programming language. Okay, and that's the name for those language which the those natives on that island. This is that language for them. Okay, fine. So clear Java. So one thing what we wanted to know was yes these two things, right? One is Java. You should actually download both the things. Fine. Get the Java language specification. Also get the JVM specifications. Fine. Latest version which is running is 8. Fine. So yeah, when it is language, okay, they'll say this is Java. You have the 1.8 or sometimes you also call it as 8. Okay. Fine, 9 will be released very soon. 9 is going, 8 is more than 2 years old. And it's more than 2 years since we had Java 8. But Java 8 was a very major change in the history of Java language. It's one of the biggest change for Java, for the Java language itself. Fine. Anyway, so yes, what we'll be discussing Java 8. Fine. As if you're just learning the Java 8. So it's like, okay, at places I'll mention that this is something which is new. So it's not, we'll not have a partition that, okay, I'm first teaching only full Java and then I'm saying, oh, this is what is additional in Java 8. We'll, in the flow, wherever it fits, yes, the new features will be mentioned. Fine. And we'll discuss things in a sequence. Fine. Okay. Fine. Now, yeah. So let's discuss a few things which is mainly about the platform independence. Let's discuss about platform independence first. See what made Java popular, that also is another question. Fine. So let's first discuss the platform independence. So people will talk about platform independence, but why exactly they were saying it is platform independent? We understand now that actually there are two separate things. One is a platform and other is a the programming language. Okay, but now if you look at the language, let's make comparison of Java. Fine, the process of executing, starting from the source code. What's the whole process? If you got a process, let's compare with C language. So if you got some code in C, what's the first step you will do? You have written a source code which is in C. Your first step would be to compile. Fine. The output of compilation is some kind of an executable. Fine. What is executable? It's made up of, yeah, it's made up of instructions. Instructions which come from a specific instruction set. It's for a specific platform. Fine. The place where you compile, fine, the output of compiler is according to where you are compiling. You compile on Windows platform, it will generate the binary, the executable, which will have instructions which take the instruction set according to Windows platform. When you compile the same C code on a different platform, let's say Linux, the output of compiling that code would be according to Linux. The executable will be made of instructions which are working for the Linux platform. Fine. So this is something, this is an executable which is specific to a platform. It works on a platform. Okay, this is linked to a platform. So this is compilation, and then we'll say, oh, we want to execute. We have to execute on that platform only. Fine. This executable created for a specific platform, and so output of compilation is dependent on the platform where you compile. And for Java, let's see what is the case. How Java is different here. And how Java differs? In case you got Java, so you got some source code for Java. Okay. When you compile, yes, it's again going to create instructions for which platform? Not for the platform where you are compiling.
Java.
It will be for the Java platform. We talked about Java is a platform. So this is actually called as Java bytecode. The output of compilation is Java bytecode, independent of where you compile. On whichever platform you compile, any Java compiler always compiles the Java code for the Java platform. The target is always Java platform and not the native platform. And I'll use the term native platform and Java platform. Fine, we understand now the difference. Native platform could be anything. Fine, the place where you are working. Fine, it could be Windows, Linux, anything. Fine, and we have the Java platform. Okay, so Java bytecode generated, which is independent of, it's for, it's for the specific platform. It's not independent of the platform. That again is for a specific platform only. But if you have seen what is a cross compiler, you know the term cross compiler? No? Huh?
Cross-platform.
Cross compiler is, what is a cross compiler? Actually, Java compiler is a cross compiler, you can say, because it's compiling for a different platform. It's not compiling for the platform where you compile. Right? In embedded systems, you normally have a similar idea, right? Because you will use Windows platform or Linux platform where you will have the tools. Fine, but then what's the target? The target would be a different platform. Fine. So, fine. So that's where we have those kind of things. We call them as cross compilers. And system programming, you must have come across compilers and right, assembler, compiler. There's a cross compiler. So Java platform compilers are always cross compilers. You can think that way. Fine. And then this Java bytecode, when it is to be executed, what is needed? What we have here is there is what we call as JVM interpreter. Yeah. How does this JVM interpreter work? It interprets the bytes from the Java bytecode, the instructions from the Java bytecode. They are interpreted according to the native platform. So here is your native platform where the thing has to execute. Fine. Using a JVM interpreter, the execution is happening here. And it uses the JVM interpreter, interprets the JVM interpreter. So Java is compiled but then interpreted at runtime. Though it is compiled, it is interpreted at runtime. Bytecodes interpreted to native code. Fine. Okay. Fine. So this is okay. Fine. Clear about this concept? Okay. Fine. So this also clarifies Java is a platform. Okay. Okay, now the next point is about how Java became popular. Fine, we understand Java is the most popular programming language now, right? So, why did Java become popular? What was the reason? Fine, how it started, how the whole journey started for Java. So, I had mentioned, like when you said, okay, platform independence, I said, okay, it's more from marketing point of view. So, it's that feature only, fine, which was used as making it popular. But how exactly it became popular? Yeah. Which specific kind of a component you may have heard? Probably, yeah. That component is now no longer being used. There's some component in Java, and no, it's something which no longer is being used. It's applet. And what made Java popular? Applet. And but it is interesting to just to understand what exactly was, how the things were working, how fine, why this made a difference, why those applet made a difference. Okay, fine. How was it different from other languages? Fine. The concept of applet, which was I'll say an innovation in those days. You should understand when this all happened, right? But yes, it is applet which brought Java into the limelight. Okay, the Java as a programming language, the project for Java as a language was started in 1991. Fine. So we had 1991. That's a year when there was a project initiated by which company? Sun Microsystems those days, fine, which was later 2010, around that time. It was in 8 or 9, somewhere at that time this process was initiated. It was taken over by Oracle. Fine, so now it's with Oracle. Fine, okay. So in 1991, Sun Microsystems, one second, excuse. Hello, hello. Okay, fine. So in 1991, Sun Microsystems, they initiated the project for, they called it as Project Green. It was called Project Green at that time. Okay, the idea which this was actually created for consumer electronics. Fine, as a language to be used for consumer electronics. Okay, but fine, this project this project was being led by a scientist at Sun Microsystems. And who was the scientist? James Gosling. He is referred as father of Java. Fine. James Gosling is referred as father of Java. नहीं, seen him but not met him.
I saw the picture.
Huh?
I saw the picture.
Huh. Fine. So James Gosling, he is referred as father of Java. Fine, he is father of Java. Okay, but this project didn't become popular. For a long time, it didn't become popular. Fine, it was only in 1995. Okay, the date actually is 23rd May. Okay, we have 23rd of May 1995 when Sun Microsystems showcased applets. Sun Microsystems showcased the use of applets on this date that Java started becoming popular. People saw something different. What was different about using applet? Fine. Okay, that feature of platform independence was quite useful here. Okay, what they had done, yes, in those days, there's another actually very popular browser which used to be there. Fine, there's a that was a most popular browser those days. Okay, but anyway, Microsoft killed that, and they kill all competition. They don't like. So we had that browser, which was the most popular browser. You may not have heard about this these days. Netscape Navigator. Have you heard this? No. Huh? Netscape. Fine. So Sun Microsystems, they had showcased using Netscape Navigator how applets can be used on internet. Fine, for the web, how they can be used. So that's something which we would like to understand, what was shown those days. Fine, what was shown by the Sun Microsystems, what they had shown in this. So yeah, fine. So let's understand what exactly, how applet is actually working on internet. Yeah. So what is internet? So popularity because of, so you can see it's 1995. That's the time when internet also started becoming popular. Fine. Before that, yes, there was not much things like internet or anything. Fine. So it's internet and Java has grown together, you can say. And Java has grown along with internet, and yes, internet was used for growth of Java, you can say. Okay, so what exactly was happening in these days? Fine. So we understand in internet, yes, what do we use? Most common things as a client side, what would you use? A browser. Fine. So you have a browser. Fine. And internet is based on another thing. In a browser, you give some input. What's the input we give here? You write a URL. Fine. You give a URL to your browser. Fine. When you give a URL to a browser, what exactly is happening? Okay. For that, let's look at a typical URL. How does it look like? HTTP colon / then yeah, okay, www dot
Name of website.
okay, something. Oops. Or MSU Baroda .ac.in, then / maybe there's some path, and then / something .html. Let's take a simple case because I'm going back to 1995. Right. So there in 1995 it used to be all HTML most of the time, right? Internet means okay, there is to be HTML. And internet was HTML was something what people used to had started learning about HTML. Okay, fine. So yes, that's what is a typical input to the browser. So you give this input to the browser, sorry. Yeah, when you give such an input to the browser, what will the browser do? How is this input going to be used? What does this refer to? Host. It refers to some machine on the internet. Fine, it refers to some machine on the internet. This would actually be resolved into an IP address which identifies some machine on the web. So when you give this input, first thing which is done by the browser is uses this, and there's actually also possibility of a port number being mentioned. Fine. So it makes a TCP IP connection. And it makes a TCP IP connection to, okay, this has identified host But when it is HTTP port number 80, so make a TCP IP connection with some process which is working on a host. This is a host. On this host, there is some process, and that process will call as HTTP server or the web server. Fine, like Apache or some such things. Okay, fine. So what it does, this input is used so that it can make a connection to that. Made a connection. And on this connection, it has to start communication. The communication has to be according to HTTP. I must follow the syntax of HTTP on this connection. Okay, and then this is the other part which is then to be used. This is a name of a resource available on the host. URL, it refers to a resource. So fine. So on this connection, it will send a message. It will communicate using the HTTP protocol, and it will, in HTTP protocol, it will say, okay, oh, get me, and this part, right, slash this, okay, something dot HTML, get me this. I want the content of this. That's what the browser has given to the server. When server receives this request, it's a request which is coming from a client. Fine. In this case, the client is the browser. Fine. What will the server do here when it receives such a request? I want that HTML. Fine. It has to locate that resource on the local machine, on the server's machine. Fine. So somewhere maybe there is some content, HTML content available, right? And this content is given back as a response to the browser. Okay. What does the browser do with that response? Fine. In the response, it gets a content which is an HTML content, and it starts rendering the content, displaying. Fine. It understands all kinds of formats. Fine. Browser is very versatile. It understands. It's a very versatile client and meant for rendering all kinds of content. You may have video content. You may have any kind of content. I can handle all contents. If you have PDF content, oh, I have, maybe if it can't handle, it will say, okay, I can save it for you. Any content which arrives, either it says, if it can handle, it can, okay, if it can display, it will be displayed. Fine. But anyway, HTML was very basic, and that was something which was always available. Fine. So it would start rendering the HTML. HTML made up of tags. Okay. So it would come across lots many tags, bold, italics, and everything. Fine. So yes, it knows how to render that. But then if it comes across a tag like this, image src equal to something.jpg, and there are other attributes. Suppose such a tag comes, the browser comes across such a tag. What will the browser do now?
Find out that JPG file.
Where?
Server.
But this is tag which is received by the browser.
It will have to request.
It will again make a connection. Fine. Again it makes a connection, and on this connection sends a request, just like it was requesting HTML. This time it says, okay, get me that thing .jpg. Okay, and then it sends a response which is nothing but a content of the JPG, and it knows how to render JPEG. Browser is very versatile. It knows how to render different kinds of content. It knows all kinds of formats. Fine, it can handle JPEG. Okay, I know how to render JPEG. Fine, it starts rendering images. Okay, so what was done here, what Sun Microsystems did is they said, okay, just like images can be rendered, it added a new tag. It says, let me have a tag called applet. Okay, you have attribute called code equal to, and here is something which would refer to a Java bytecode. Fine. This is something which would be a Java bytecode, and other attributes, width, height, and other things. So what was applet? Applet was basically a Java component, compiled Java component, which would be available and deployed on the server side. Yeah? For your website, you are keeping your images on the server. Fine. Whenever you have a content, the HTML, images, everything is being kept. Or same way, we even have a Java bytecode, the applet. It's a code, remember, executable code. Fine. Fine. It's not like content. It's not like other content. Other content are very static things, right? Images and all those things, they're contents. But this is not content. This is, though we treat it like a content, right? Fine. So this was what was the innovative thing here. What they did is they said, okay, if you come across applet tag, Netscape Navigator was trained so that it could make a connection with the server and find and get the content which is a Java bytecode. So get the Java bytecode content to the browser, and then within the browser, see what is needed for Java bytecode to execute? The JVM interpreter. So this Netscape Navigator at that time, they made it have a JVM interpreter. So it was having a JVM interpreter, and then the applet would work within the browser itself. The applet execution of applet would be initiated within the browser. So we had an executable part which was deployed on server, okay, and then you move to any part of the world, ask for a web page, and along with the web page comes your client code, executes in your browser, and doesn't matter on what platform you are working. Fine. So that's the idea. That was something unique what they had shown at that time. Fine. Okay. Nowadays, yes. Then afterwards, lot many things have come up on similar lines, right? Earlier, people used to only think about content that can be transported, but then okay, let executable also be transported from server to the client, and the client code works here. Fine. You write once, deploy it only at one place, and use it from anywhere. Fine. So once this was displayed, then people said, oh, there is some language for the internet. Oh, we have this Java, which is the language for the internet, a programming language for internet. That's a label Java got. But Java is not a language just for the internet. It's a general purpose object oriented programming language, and from Java 8 you can say they also have done a fusion of functional programming. So it's not only object oriented programming, we also have features of functional programming for which the fusion is done from Java 8. So Java 8 gives you some features of functional programming. Fine, clear, fine, you have understood what's exactly how the applet is working. Fine, we are not trying to go into what is applet exactly, fine, but how the working, fine, and why it became popular. So because of this, Java became popular. It's the applet which has made Java popular. Okay, and now what? What's happened to applet? It's not applet. From HTML5, fine, browsers are now compatible with HTML5. In HTML5, all kinds of plugin technologies are being thrown away. Fine, this is a plugin, JVM interpreter. Fine, so same way, even Flash and other things, Flash kind of things, they are going to go away. Fine, you want videos, or you have proper videos. Fine, HTML5 has to support. Fine, all browsers, they should be supporting all kinds of content. Okay, fine. So it's nothing but they are throwing away all kinds of plugin technology. Okay, fine. That's one thing. Like why applet is also going away. Fine. So it's not okay. So we will not be learning about applets. Fine. We'll rather be looking at all the features of Java 8. Fine, that's what we'll try to cover more. And so we'll have more concentration on that side. Okay, fine, clear on this? Okay, so fine. So Java became popular because of applets. Fine. Other feature, Java is object oriented. Okay, so is fine. You have seen object oriented programming using C++. Okay, fine. But C++ is different from most of the other object oriented programming languages. You'll realize that later. Fine, that C++ is something different. It's this slightly negative point about C++. Okay, fine. Yeah. C++. What is C++? It's an extension of C. It's not a new language basically. That's where the fault lies. Okay, it became huge because it is compatible with C. Any C code is a valid C++ code. Is it not? Right? And that's where it has become a very big language. It's too huge. Fine? Okay, it's not just only, okay, see, it could have been something which is just purely object oriented kind of things, fine, with object oriented features. Okay, but C++, they said, okay, whatever is there in C, that should be there. But yeah, the advantage at that time was to quickly have programmers who already know C, because C was a very popular language. Fine, so there were so many programmers available for C. Oh, so they may, they may very easily shift to object oriented programming. So maybe you don't do all the things object oriented, so we have a mix of both. Fine, but anyway, it became too large, and that's what C++ is. Okay, so we'll be talking about Java now. So let's again look at what is object oriented programming. Fine, let's try to understand and look at the things from a very different perspective now. Fine, coming to exactly what is programming now. Yeah, so what is programming about? A very important aspect in programming, there are two things we use. One very important thing is about data types. And in programming, yeah, you'll always have data types. Any programming language, you'll have data types. And given a data type, you have a set of operations which can be done for that data type. Fine. For a given data type, okay, if I say this is the data type, yes, then you'll say, okay, oh, this is what I can do with this data type. What can be done with anything which is of that particular type. Fine. Okay, so let's look at the various programming languages from the perspective of data types and the operations for the data type. I'm using this term as operations to mean either operator, functions, or any such things. Fine. Okay, so we have something like this. We got programming languages here. So we have programming languages. We had low level languages like assembly language, machine language. Okay, in case of assembly language and machine language, our data types were fixed by the language. Language has decided that you will have a data type called byte, you will have word, you will have double word, you will have string. Okay, that's it. You can't create your own new data types. So fixed by the language. And then if I know it is word, I have my instruction set which says, okay, you can do add, multiply, fine, you have, Fine. In the low level language, yes, your instruction set decides is also predefined. Fine. So what operations can be done on on anything which is of this type is also fixed by the language. Fine. Fixed by the language. Fine. Decided by language. Then we came to higher level language like C. I'm not talking C++ now. Fine. So we had high level language, let's say high level language like C. Okay. Example is C. What happened in C? What about the data types? Yeah, we had data types available from the language, but then you could have programmer also defining his own data types. New data types could be created. So we'll say we have what we call as data types are programmer defined. But then for the new data types which the programmer is creating, what about the operations? Fixed by the language. And the operations were still fixed by the language. Now you get the point. Object oriented programming. Data types. Yes, you have programmer defined types. What about the operations for the new types which are being created? It's a programmer defined type. What is a class? Data type. Fine, you are creating a new data type. But then you are also, when you are defining class, you are creating a new type, but for that type, within that type itself, you have mentioned what are the interactions, what are the operations which can be done if you have something of this type. This is also programmer defined. Fine, so programming is same. Any language, programming is same. It's only that now programmer has more capabilities and there are more expectations from the programmer. And he has to be more responsible also. Because when you create a type, it's something which has to be. What are data types? Again, they are used by programmers. Right? Data types are used by programmers. When a language is saying I allow you to create new data types, that means what? It means that programmer creates types which will be used by other programmers. Fine. He is able to define new data types and those data types will be again used by some other programmers. There's a lot of reusability which is now there. And something which I think of, right? Okay, I think date. Yeah, date is a data type. Fine. Or I can think of anything in the world, from real world, and you will come across a data type. Fine. What you need to think is what kind of interaction is possible with that type? What kind of operation should this data type support? Fine. And then once you define such a thing, you have created a type, you have got your what we call as an abstraction. Fine. You create your own abstraction which would then be available and used by others. Fine. Library of data types. It's all about developing data types, object oriented programming, and especially Java. When you do C++, no, you may not be thinking purely in terms of data types, in terms of distributing the data types, but Java, yes, is from that point of view, it's very, portability, you can say, and is very good here in Java. So, fine. So, as I was mentioning, yes, when you think about things in the real world, fine, you can find data types for everything. Everything put as a class, fine. Okay, so to understand what is this object oriented programming, let's take example from real world. Fine. How problems are solved in real world. Object oriented way of solving is similar to real world way of solving problems. In real world, problems are solved by collaboration. Fine. Collaboration means you will have interactions. Fine. You will have interactions. So let's look at an example from real world. Fine, and try to understand what is this. Link it with object oriented concepts. Okay. So to take an example, yeah, let's say our problem here is we have a friend in Calcutta. Okay, so we have our friend in Calcutta and we want to send flowers to our friend in Calcutta. So sending flowers to a friend in Calcutta from here, from Baroda, yeah, let's say. So you want to send flowers to a friend who is in Calcutta. So how do you go about it? We are looking at what kind of interactions we are going to have. Fine. Maybe we interact with someone and then that guy in turn may interact with someone, and so the various interactions which are happening, fine, in order to solve a problem. What is the problem? Oh, we want our problem is we want our flowers to be sent to a friend. Fine. Yeah. What we know. What's the information we have? Name and address of that friend, and we have decided what kind of flowers we want to send, how much quantity. Okay, now go ahead. Yeah. How do we go about solving this problem?
We can contact the person in Kolkata.
Straight away to the friend?
No.
No.
Flowers.
Okay, maybe you don't know.
And
Let's have better interaction. We want more interactions. So you can start with some. You'll have more people. You may know more people in Baroda itself.
purchase a flower in Baroda.
Okay, but then those are flowers. You plan to purchase it here and send it there. What condition they'll reach?
Within
These are flowers.
1 or 2 days.
What? So
They will reach in 1 or 2 days.
So what's the other solution? You go to someone in Baroda itself, maybe, fine. So let's say we go to, in Baroda we have got someone called JK Florist. Fine, we go to JK Florist and we have an interaction with JK Florist. What is the interaction? What is the instruction you are giving?
Send flowers to
Yeah, you're saying send flowers, that's the interaction. And when you have this interaction, what's the information you will have to supply? Name and address, the type of flowers, the quantity, minimum this information would be there. Okay, so you have an interaction with JK Florist and you're saying send flowers. Okay, when you do this, how does JK Florist start processing this? He will look at name and address. He finds this is not a local address. If it's a local address, I'll do something different. And if it's in Baroda and someone has said send flowers, I know what to do, right? But if it's not in Baroda, then
contact.
so he looks at the address first, finds out, okay, it's not a local one, it's a different. So then what does he do? He refers to a diary. He maintains a diary, city wise, town wise. I have different contacts. So he has a contact with someone in Calcutta, let's say KK Florist. Fine. So he interacts with KK Florist. What is the interaction?
Name, address, and contact.
What is the interaction I'm saying? What is the instruction he is giving?
Send flowers.
7 flowers. Okay, this is send flowers. And same information repeated. Okay. Now KK Florist again starts processing. How does he go about? Checks the address. The address is local address. Okay, so if it's a local address, next what he'll do, look at the type of flowers, and then he has another diary. Who is the flower producer for these kind of flowers? He is managing type of flowers and who is the flower producer. So according to the type of flowers, he interacts with the flower producer. So there is a flower producer with whom he is interacting. What's the interaction?
Type of flowers.
Get flowers. The instruction is get me these flowers. Specifies the type and quantity. Fine, the type and quantity would be the information provided with the instruction. So instruction and you have information. Okay, so and he says get flowers. Fine, the flower producer will be giving it the flowers. Okay, once he's got the flowers, he's got the name and address already. What's the next thing?
Delivery boy.
Yeah, he is going to a delivery boy. He interacts with the delivery boy. What is the interaction with delivery boy?
Send flowers.
Delivery boy is not only meant for sending flowers, he can deliver anything. So he just says deliver, and gives it name and address and the flowers, and then this delivery boy goes and delivers to her friend. Right? So in order to solve a problem in real world, we are having a lot of interaction which is taking place. Fine. There is an interaction. Of course, whenever there is an interaction, you will have some data associated with it. Fine. The kind of instruction which you are giving. Okay. Fine. Now, let's associate with what we have seen in object-oriented. We understand by the various terms used in object-oriented programming. First thing was abstraction. And you come across abstraction. Okay. Next. Yeah. Inheritance, polymorphism, encapsulation. So let's try to understand those terms here. Let's associate those things here. Some of those things can be seen here. Okay. You went to JK Florist and said send flowers. Right? JK Florist understands send flowers. Why? Why JK Florist understands send flowers? Instead of JK Florist, you go to Mochi and say send flowers. Will he understand? Yeah. He is a florist. Fine. He understands send flowers because he is a florist. So what is florist? Data type. Fine, we say florist is a class in this case. Fine. JK Florist and KK Florist are objects. Fine, they are the objects of the class florist. Fine. Class, because they are of this type, class is like the type, right? Because they are this type, and therefore this is the kind of interaction you can have. This is the kind of operations you can have. Because something is an int, therefore you can do addition, subtraction, multiplication, division. See, a type and a set of operations. Fine. For a type called florist, we have a set of interactions. Clear? But only thing, yes, this is not from the language. You have your abstraction. You have created your own abstraction of something called florist. From the real world, you have created an abstraction and said, okay, florist will have one of the interactions as send flowers. There will be more interactions which will be possible. Fine. Okay. So we have JK Florist being of type, sorry, JK florist is of type florist. Okay, we have florist. Okay, so one interaction was sunflowers, but then you also can have another interaction with JK florist. For example, you'll have some interaction with JK florist which is about why. Okay, some commercial things. For example, okay, give me a bill, accept this payment. When there are interactions about accepting payment, getting a bill, okay, all those interactions, JK florist understands not just because he's a florist. Or even that mochi would understand similar things. Our grocer also understands similar things. Okay, it's because they are all shopkeepers. Fine. You can go and interact with JK florist and say, how are you? He understands how are you. Not just because he's a florist, not just because he's a shopkeeper. There's something he understands because he is a human. We have something which is a still bigger type. Fine. Humans. All shopkeepers are humans. All florists are shopkeepers. Fine. All ints are long. Okay, we have inheritance already, okay? Fine, all ints are long. Fine. See what is meant by inheritance? It's nothing but a relationship of supertype and subtype. Superclass and subclass. In class here we say these are classes, fine, because these are programmer defined. Fine. Okay, so in classes you will have the supertype subtype relationships, so which we call as superclass subclass. Fine. So another thing which you observe here is that a subclass has more functionality compared to the superclass. Why? Because the subclass inherits all the functionality of the superclass and it can add more to it. And every functionality of superclass is inherited. This is where we have inheritance. If any operation is defined for superclass, it will be available in all its subclasses. Fine, all the subtypes. Fine, all operations available for long is available for int. Fine, additionally, when in case of C language, you can't do a increment decrement on a long type. Fine, that's an additional thing supported by integer type. Fine, it's a super type subtype relation. Fine, there is inheritance. Fine, because there is inheritance. Fine, because there is inheritance even in language like C. Yeah, we have inheritance of types. You can see this. So if I have some function f and this has been defined for the type long, okay, fine. And if I want to invoke that method, I have got int x equals to something. Int is a subtype. I can still say f of x because int is a long. Int is a subtype. And this works? Yes. Right, in C language. So we have inheritance there already. It's just about having supertype subtypes. And the concept is just, okay, wherever this type is specified, I can use all its subtypes. And every type may have further subtypes. If you are saying this is there, right? See why it has to work? Because any operation available on long is always available on int. Because inside this function, what would have been done? Some operation on A is going to be done. If any operation on A is done, yes, it's applicable not only to long, it's also applicable, it's something which is also available for int. Fine, inheritance. Fine, so we have understood what is the relation. What's the relation between object and class? Yeah. So we have these terms about object oriented program. What's the relation between object and a class? Object and class relation. Object is a instance of a class. Fine. This is class means data type. Class means data type. It's just a specification. It's not the actual thing. It is the specification. Fine. It's a blueprint. It's a blueprint for the objects. Objects are the actual things. There, objects are the actual existence, something which exists, and that's a definition. Okay, fine. Okay, so we have object and class relation. Fine. Next, another thing which we have already understood is inheritance. Concept of inheritance. Okay. Now from real world again, let's associate another thing. Fine. Inheritance from real world is okay. Fine. Is a relation. Basically, it's nothing but inheritance signifies is a relation. Right. Fine. Is a relation. We have shopkeeper is a human. Florist is a shopkeeper. Fine. So is a relation. Remember that. That should be used for identifying where we have inheritance. Okay. Fine. So inheritance, it allows, see, this principle of inheritance is something which allows a programmer to define a new data type which is a subtype of an existing type. Fine. It is fine. Because of this, you are able to create. Fine. See, programming, object-oriented programming is about creating data types. Fine. So you are able to create a data type from an existing type as its subtype. And creating subtype. That's what inheritance is. Okay. Then we have. Now we have. If you look at that interaction, what was the interaction? Send flowers. When you said send flowers to JK florist, what did he do? Looked at the address and then, after looking at the address, what did he decide?
To contact Kolkata person.
How? How did he decide? He had to look into a diary. Oh, that diary. If that diary was available to all, then he has to keep it with himself, right?
Yes.
It shouldn't be available to all. Right? If it was available, then what's the problem?
We can direct contact to the
Okay, directly contacting is also fine. That's not a big problem. A bigger problem is, fine, the bigger problem is whether that diary will remain the sanctity of the diary. Anyone can go and make any kind of entries in the diary. Fine. The read access is not as bad as the write access. And you are giving write access to everyone. And you don't know who makes what kind of entries, who is responsible for those entries. Fine. Okay, so here, fine, you can, in real world, we have also got information hiding, or what we call as data encapsulation. Fine. The diary is a data structure which is hidden from others. Fine. Right? If you want, you are free to give information to JK Florist, but it's he who will make the entry. You can give information to JK Florist. Oh, I know someone in so and so place, and you can note this name and address. He will verify and then make the entry. Fine? But you can't make entry. Okay? Clear? So from real world, right, we are associating with real world things. Inheritance, data encapsulation, and polymorphism. Okay, other thing was polymorphism in this case slightly difficult, yeah. We'll have more polymorphism. We'll have more examples of polymorphism later on, fine. But yeah, what exactly is meant by polymorphism? Yeah.
Same function in superclass and subclass.
Okay, fine. So we have different types of polymorphism. Fine. The common terms in programmer for programmers would be what we call as overloading and overriding. Yeah. Okay. Example related to overloading first. Let's see. Yeah. What exactly would be overloading? Okay. For overloading, let me give another example from real world. Okay. You may come across things like what is a, has anyone known what is a plotter? Like printer, there's also a plotter. Fine. Plotter is more like a mechanical robot, robotic, fine. It's not exactly a robot, but yes, plotter, it used to be a big, you have huge sheets, okay, which go in a plotter, and then the plotter has a horizontal and a horizontal arm, fine, there will be a horizontal arm, okay, there will be a horizontal this thing, and this entire things can move up and down like this. Okay, and within that arm there will be one pen which can move left and right. So it can cover the entire paper anywhere, right? So it can be instructed to draw various kinds of shapes. Fine, it could then be instructed to draw various kinds of shapes. Fine, it can move anywhere, right? So X, Y, those kind of things. So plotters, so good drawings they could be done. It even had some plotters would even have a mechanism of supporting multiple pens, so it can come and pick up a pen of a particular color and then draw using that. Fine. So different color things and all those are anyway. These days you don't have those plotters, I think. But yes, those things were there anyway. Printers and plotters, that used to be the terms used. Like, okay. So anyway, so let's just think about interaction with a plotter. Fine, we'll talk in terms of interactions. So you have a plotter object. Maybe there's some plotter object. What kind of interaction you have with this? You can ask it to draw a line. So you can say, okay, I want to draw a line. So when I say draw a line, what is the input? Draw line. What's the input?
Shape and curves. Shape.
Drawing a line. The shape is line.
Length of point.
Yeah. Color can also be there, but okay. For the timing, let's say there's only one pen. It has.
Length of line. Starting.
Yeah. Starting point,
And
ending point. Just give the 2 points. Fine. You can give the 2 points and you can draw a line. Okay. Another interaction would be draw a circle for me. Yeah, so if I want to ask it to draw a circle, what inputs?
center.
A center point and radius. Okay. Now we have someone who's got 3 points in a plane. And there's someone who's got, there are 3 points in a plane and he wants to have a circle which goes through that 3 points in a plane. So what that person will have to do if he wants to draw a circle? From those 3 points in a plane, he will have to calculate the center point and radius, and then only he will be able to interact with the plotter. But there's a standard way of doing that calculation. Given 3 points in a plane, there's a standard calculation for finding the center point and radius. Fine. Given 3 points in a plane, find center point and radius. Fine. And then interact with the plot and say draw a circle. Now if that calculation is something which he makes a mistake in, he is going to still say, oh, that plotter is wrong. So in order to avoid such things, what the plotter says, okay, if you give me 3 points in a plane, I can do that for you. So it says you can draw a circle if you give me center point and radius. You can also draw a circle if you give me 3 points in a plane. And I'll do the calculation. Fine? That's overloading. It's doing the same thing, but type of inputs are different. Fine, the inputs here were center point and radius, here inputs are 3 points. Okay, and so this is one kind of polymorphism. Now another kind of polymorphism which refers to the overriding part. Fine, what is overriding? Overriding actually refers to what we call as, it is about exception. It is an exception to a general rule. It's an exception to a rule. How is it an exception to a rule? You got a type, you got a class, fine, where it defines something. It says, okay, there is this functionality, this kind of a message, I understand this message, and if someone gives this message, I have a particular way of working. I have got a particular way of working. This is normal, and this is what normally should happen. But then I have a subtype, one special case where this same functionality is done differently. It's not that functionality is not understood. A subtype has to support all functionality of supertype. But then instead of inheriting the functionality, it is overriding the functionality. It's not just inheriting, it can be overriding the functionality. Okay, a very abstract kind of example I am giving. Fine, for example, we have a class called mammals. Fine, mammals will have offspring. Mammals have offspring, but we have platypus, which is a mammal, but it is an exception to the rule. It lays eggs. Fine, it does something differently. Fine, for all things which are mammals, this is how it happens, but I am overriding. It is overriding that one behavior. Fine, it's doing something differently. It's not inheriting. It's not done the same way as it's done here. It's a change to the rule, exception to the rule. Because superclass is general, a subclass is a specific type. So it's a exception to the rule which is done for a smaller kind. Fine. General is superclass. Okay, superclass is more general. Okay. Fine. Just another way, again a very vaguely abstract example. Okay. Fine. If you consider that same shopkeeper example, fine. You go to a shopkeeper or you go to humans. All human understands how are you, and there is a specific way. How there's a normal behavior for reaction to a how are you. But when you go to the shopkeeper and say how are you, The shopkeeper can become extra friendly because he thinks you are going to be a good customer for him. Fine. So he is overriding. What is he is not doing exactly the same way as a normal human does. Fine. So this is what we have as overriding. He is overriding that functionality. He can't say, no, I don't understand, how are you? Fine. It's there for humans. He is a human. He has to understand. But he can do it differently. He is not doing it exactly the way it is for all humans, normal. Fine. There's some normal, but this is exception. Okay. Fine. The other kinds of polymorphisms, right? Fine. As we look at the programming language, we'll come across those terms. This is more from understanding from the point of view of trying to associate things with the real world. Fine. The object-oriented concept. What are the concepts we have seen? We have seen what is meant by abstraction. What is meant by abstraction? It's a process of identifying. Fine, we identified florist, we identified things called flower producer, we identified a thing called delivery boy. Fine, a delivery boy is someone who has these kind of operations, who will understand, deliver. Fine, that's a delivery boy. We are defined actually a type, and we are putting functionality into it. This type, these are the types I have identified, these are the functionality it should have. That process which you are going through, right? That's some process you'll have to mentally go through. And that is what you are doing as abstraction. Fine, you have done a abstraction. Okay, and then we had, object and class. These are, I'm just listing those terms, object and class. Fine. Object is an instance of a class. Okay, fine, that relation is known. Then we had seen inheritance. We have seen data encapsulation. And we have tried to understand a little bit about polymorphism. Fine, so any questions in all this? Fine, any questions here? So far, anything? Yeah? Yeah?
Coupling and cohesion are add-ons.
Which one?
Coupling and cohesion.
Okay, that's about actually the style of development. It's more related to the way you do your development. You can think of classes, but how you break your classes, it's from that point of view. And when we talk of coupling and cohesion. Fine. You shouldn't have tight coupling. Fine. So it's about how you are designing your classes. It's related to the design of classes. Yeah. Every class should have exactly, it should be for one specific purpose. That should be clear. Fine. Yeah. You can read about what are object-oriented principles. Fine. OOP, object-oriented principles. Fine. You should start reading things. Fine. You want to become something, it shouldn't be like everyone else in your class. Fine. So if you want to make some difference, start reading materials. Fine. So you can read on what are object-oriented principles. Fine. Just try to understand. You'll get good ideas about, yes, a good design, class design, how to have good class design. Okay. Fine. Yeah. Okay. Fine. So any questions, any of these things here? Java as a platform, Java as a language. Fine, download JLS. Fine, you should be able to just look for JLS. You can type JLS and you should be getting the Java language specifications. Fine, and do it for Java 8. Fine, Java Platform 8. Fine, and yeah, install JDK. Fine, just pure JDK. Fine, currently we don't need some IDE or anything. You may not have IDE. Fine, just without any ID we can just get started. Plain text editors can be used, and you can have a good editor. Okay, if you are using Windows platform, you can have Notepad or something. Fine, so that should be a good editor. And yeah, we'll be doing more things from command prompt. Okay, fine, they're simple commands, you'll understand all of them. Okay, fine. So for today I think, yeah, that's what we have. And tomorrow what we'll do is we'll try to look at developing how do we compile, execute a Java code. Fine, writing our first Java application. And it's not only just about writing a small application like hello world. Fine, we'll also understand the structure of a Java file, what goes in a Java file. Fine, fine. So yeah, fine. So yeah, if any other questions are there, then otherwise fine. And tomorrow 6:30. Okay.